Good morning students, welcome to Konnur online classes. Previous classes we can discuss the concept of permutation. Here permutation and combination is a very important as a very essential topic. That's why first we can discuss a very important concept, that is permutation. Permutation means it is the arrangement of numbers or elements, anything. Here permutation means it is a arrangement and a combination means it's a selection. Here in case of permutation we can define a very important formula, that is NPR. Here n value is greater than R value. First given things that considered as n things, in those n things we can select only R terms. That's why NPR, in NPR, n value must and should be greater than or equal to R value. That's why NPR is equal to n factorial divided by n minus R factorial. Here n factorial means that is n minus 1, n minus 2, n minus 3, so on up to 3 to 1 of two extendable last one. Here this is the discussing concept in the previous classes. Regarding to that one, we goes to next concept is circular permutation. Circular permutation. Here permutation is a arrangement. Here arrangement of numbers or things or name of the students or name of the persons be arranged in a circular path. How to get the circular path arrangement? Here to study the circular permutation, here definition of circular permutation means arrange the things or name of the persons we can arrange in a closed path or circular path. The arrangement of numbers or elements or anything in a closed path is called circular permutation. Here for example we consider A, B, C, D. 4 element. We can consider A, B, C, D. 4 element. These 4 elements can be arranged in a circular path, that is A, B, C, then D. A to B, B to C, C to D, and D to A. This is a circular permutation. Here circular permutation means it is a closed path or circular path of arrangement of given things, that is called circular permutation. Consider a 4 element, that is A, B, C, D. In a 4 element arranged A, B, C, D in a circular path or closed path, that is called circular permutation. For example, we can consider only 3 terms, that is A, B, C. A to B, B to C, then C to A. It's a closed path. That also is considered as a circular path. Only 2 elements are given, that is A, B. Here A to B, then B to A is also one type of circular permutation. Circular permutation is a one thing, that is a closed things we can consider as a circular thing. That's why here circular permutation is represented by the formula, that is n factorial divided by n. N factorial divided by n. Here n factorial can be extended as n minus 1, n minus 2, n minus 3, so on up to 3, 2, 1 divided by n. Here n n value get cancelled. Here remaining n minus 1, n minus 2, n minus 3 and so on up to 3, 2 and 1. Here it's represented as n minus 1 factorial. N minus 1 factorial. This is the formula for circular permutation. Here circular permutation is equal to n minus 1 factorial. Here this is our formula for circular permutation. Here circular permutation means it is a closed path of arrangement of given things. Here consider A, B, C, D. 4 elements. We can arrange A, B, C, D in a circular path. This is the circular permutation. Only 3 elements are given, A, B, C, arranged in a circular path. Only 2 values are given. Then only you can arrange it in a circular path. Here circular permutation can be expressed as a formula n factorial divided by n. Here n factorial can be extended into n minus 1, n minus 2, so on up to 3, 2 and 1. Here divided by n get cancelled, get n minus 1 factorial is our circular permutation values. Circular permutation is one type of permutation. Here all things are arranged in a closed path. Closed path is called circular permutation. Circular permutation can be expressed as n factorial divided by n. Its formula is n minus 1 factorial. Here on the basis of that, circular permutation is equal to n minus 1 factorial. Here this is the important formula for remembering circular arrangement. Here on the basis of that fact, we consider one example. Here how many ways can 8 persons be seated? In how many ways can 8 persons be seated at a round table? At a round table. Here let's consider one round table. Here in this concept, person 1, P1, P2, P3, P4, P5, P6, P7, P8. Here, in how many ways can 8 persons be seated at a round table? Here, consider P1, P2, P3, P4, P5, P6, P7 and P8. Consider 8 persons be arranged in one way. We can arrange 8 persons in one way. In the same concept, in how many ways we can arrange 8 persons in a round table is our questions. Here, in circular permutation, we can consider it as circular permutation. Circular permutation is equal to n minus 1 factorial. N minus 1 factorial. Here in this problem, n means, here in this problem, n means number of persons. Here n value is equal to 8. N value is equal to 8. That's why in how many ways can 8 persons be arranged in a round table means 8 minus 1 factorial way, that is 7 factorial way we can arrange here 8 persons in a round table. That's 7 factorial means 7 into 7 minus 1, 6 into 5 into 4 into 3 into 2 into 1. Multiplying we get our answer. Here in case of 8, 10 persons be seated at a round table. Means here taken 2 extra, P8, P9 and P10. Here circular permutation n minus 1 factorial. In this case n value is 10. N value is 10. Here 10 minus 1 factorial. 10 minus 1 means it's a 9 factorial. 9 factorial can be expressed as 9 into 8 into 7 up to 1. Exchange. Multiplying, we get our answer. Suppose here circular permutation means it's a closed path. It's a closed path. We can arrange the numbers or persons, anything given that can be arranged in a closed circular path, means it's a circular permutation. Here in this circular permutation we can we get circular permutation is equal to n minus 1 factorial. Here n means in this problem number of persons. Number of persons is represented by in circular permutation. Corresponding we get 9 factorial and 7 factorial values. Here suppose next concept is, suppose in circular permutations clockwise as well as anti-clockwise rotation is not be recognized. In P1, P2, P3 is one side be noted, another side also noted. That's why here in a circular permutation clockwise as well as anti-clockwise measurement is possible, then circular permutation is equal to n minus 1 factorial. Suppose circular permutation, in a circular permutation we cannot be recognized here clockwise as well as anti-clockwise notation. Here formula is changes to circular permutation is equal to n minus 1 factorial divided by 2. N minus 1 factorial divided by 2. Suppose clockwise and anti-clockwise notations are recognized by the problems, with circular permutation is represented by n minus 1 factorial. If it is not recognized by clockwise and anti-clockwise conditions, here circular permutation is equal to n minus 1 factorial divided by 2. Here these two are very important and a basic essential formula belonging to the circular permutation. Here consider the next problem. In how many ways can 10 different precious stones be set to form a necklace? Here in necklace form, here in this form 10 different precious stones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here 10 different stones. How many 10 different stones can be arranged? 10 different stones can be arranged in a necklace. Precious stones be set to form a necklace. Here in this form we can easy to recognize clockwise as well as anti-clockwise rotation. That's why here circular permutation is equal to n minus 1 factorial divided by 2. That's why here in this problem n value is number of different stones. Here given a number of different stones, value is n is equal to 10. That's why circular permutation is 10 minus 1 factorial. Here is equal to 9 factorial, sorry, divided by 2. 9 factorial divided by 2. Here our, in how many ways can 10 different precious stones be set to form a necklace? Consider 10 different types of stones. Here circular permutation means n minus 1 factorial divided by 2. Here n means number of different stones. Number of different stones. Here n value is 10. That's why here substitute in place of n 10, that is 10 factorial divided by 2 is our answer. Similarly, in how many ways can 6 boys be arranged in a circle if 2 particular boys always want to be together? Consider in a circular path. Circular path. Here, in how many ways can 6 boys be arranged in a circle? Here, this is a circle means it is a closed path. That's why we consider one circle. In how many ways can 6 boys be arranged? Consider that is a B1, boy number 1, B2, B3, then B4, then B5, last finally B6. Here these are 6 boys be arranged in a circular path. Especially out of these 6 boys, if 2 particular boys always wants to be together. Consider any 2 persons. That is, we can choose B1 and B2. These 2 boys always wants to be together. That's why here it's naming as it's a particular one. 1, this is a 2, this is a 3, this is a 4, and this one is a 5. Here number of sets of boys is 1, 2, 3, 4 and 5. Here these 2 particular boys wants to be together. That's why we can consider as only one set. Here circular permutation. We know the formula circular permutation. Circular permutation is equal to n minus 1 factorial. N minus 1 factorial. Here n value is 5. Here n is equal to 5. That's why 4 factorial. 4 factorial is our answer. Then here next problem is B1 and B2 wants to be together. That's why these 2 persons always wants together. Consider as a 2. Here 4 into 3 into 2 into 1 into 2 into 2 1. Here simplifying we get our answer.